Hello, I am Dhruv Verma. In this lecture, we are going to learn about Bipolar Junction Transistor, which is also known as BJT. BJT is a transistor which is used as switch and amplifiers in electronic circuits. The word transistor is derived from the word transfer plus resistor, as it functions as the transferring the electric signal from low impedance circuit to high impedance circuit. BJT is called bipolar because it has two charge carriers, holes and electrons. It is also called current controlled device because the output current is controlled with the input current or by changing the input current. It is a low input resistance device. It is also a noisy device due to minority charge carriers. The minority charge carriers uh, rise the temperature, so it is also a temperature sensitive device. It has large gain due to more conductivity. The major application of BJT is amplifier. So BJT is a three-terminal device. It has first terminal is emitter, the second terminal is base, and the third terminal is collector. So this is the structure of BJT. The first one is emitter, which is highly doped and moderate in size. The second one is base, which is least doped and also lowest in width or size. And the third one is collector. It is moderately doped, but it is larger in size, or we can say in width. There are two types of doping in the region, in these three regions. The first one is NPN and the second one is PNP. In NPN, the emitter and collector are doped with N-type semiconductor and the base is doped with P-type semiconductor. And in the PNP doping, the emitter and collector is doped with P-type semiconductor and the base is doped with N-type semiconductor. And this is the symbol of BJT. There are four modes of configuration in BJT. The first one is active mode. In this, the input terminal is forward biased and the output terminal is reverse biased. The second one is cutoff, where the input terminal is reverse biased and the output terminal is also reverse biased. And the third one is saturation, in which the input terminal is forward biased and the output terminal is also forward biased. And the fourth one is reverse biased, in which the input terminal is reverse biased and the output terminal is forward biased. So the saturation mode is used in detail transfer. The TTL is transistor logic, and the reverse active is only has one application. It has less gain. The active mode is used in amplifiers, and the cutoff and saturation modes are both used collectively as a switch. Uh, to on the switch, we use saturation, and to off the switch, we use cutoff. BJT has a diode equivalent circuit where we can replace the BJT or emitter base and collector terminals with the two diodes like this. But it is not practical, as by connecting two diodes the width of the base increases, which decrease the conductivity of the BJT, so it is not practical. Now we will move towards the working of transistors. Bipolar transistor. So this is a BJT structure with forward bias, where the input is forward bias and the output is reverse bias. Sorry, this is active region, BJT. The base is doped with P-type semiconductor, and the emitter is doped with N-type semiconductor. Uh, on the forward bias, the base is applied with high voltage and the emitter is applied with low voltage. So the current will starts to move from N to P, and the emitter current direction will be like this. and the base current direction will be like this. So and the collector region is in reverse bias, so the collector current will move towards like this. So the collector current and base current are both contributing to the emitter current, or with the help of KVL, KCL, we can say that the collector current is the sum of the base current, and the emitter current is the sum of the base current and the collector current. The base current is very low due to low doping in the base region. It is negligible, or we can say that in microamperes. So the emitter current is uh, nearly equal to the collector current. So the electrons move from emitter region to base region, then to collector region. So on moving the electrons from emitter region to collector region, some electrons are recombined in the base region. So, for example, if n electrons are transferred or moved from emitter region, then only alpha n electrons will be will move to the collector region. So the n minus n into 1 minus alpha will be the recombined electrons. So alpha is the ratio of the electrons move to the collector by the emitter. Then we can write that the current IC is alpha times of IE, emitter current, plus ICO. ICO is the current due to transfer of holes from collector to base region, where alpha is the current gain of the uh, this BJT, and alpha IE is the is the current due to majority carriers, and ICO is the current due to minority carriers. So the current due to majority carriers is known as diffusion, as here the current flows from this is the current due to the flow of electrons from high concentration to low concentration. And ICO is called minority current. Sorry, ICO is the minority is the current due to minority charge carriers. It is also known as drift current. Then drift current is the current due to the charge flow of under the influence of external voltage, like in the reverse bias voltage. Now the general current equation of transistor is IC is equal to alpha IE plus ICO. So ICO is the it is called we can call a thermally generated current, or minority current, or drift current. So from the first equation, I is equal to IC plus IB, if we divide IB both the sides, right hand side and left hand sides, we will get this ratio and this ratio. Now what is alpha, beta and gamma? So alpha is the current gain of uh, common base transistor, and beta is the current gain of common emitter transistor, and gamma is the current gain of common collector transistor. Then alpha is equal to IC upon IE, and beta is equal to IC upon IB, and gamma is equal to IE upon IB, where IC is the output and IE is the input. Here IC is the output and IB is the input. Here IE is the means emitter is the output and IB the base is the input. So we will get this equation, and if we divide the first equation by IC both the sides, then we will get this relation, the relation between alpha and beta, and the previous one was the relation between gamma and beta. From this relation, it is clear that alpha is will always be less than 1, as it is beta upon 1 plus beta, and alpha will also be always less than beta. And from both the this and this relation, we will get alpha is the largest, then beta, and the gamma will be largest, then beta, and alpha will be the lowest. And this is the overall relation between alpha, beta and gamma. Then from the equation IC is equal to alpha IE plus ICO, if replace alpha with the beta relation, then it will be IC is equal to beta upon 1 plus beta into IE plus ICO. On multiplying and dividing the IB on the numerator and denominator with the IE, we will get this, and IE upon IB is gamma, as also we know that the gamma is equal to 1 plus beta, then it will be cut out and we will get the equation IC is equal to beta IB upon plus ICO. This is the most important result of this of the BJT. ICO is equivalent to the ICEO. ICEO is collector to emitter current if base is open. Now we will understand what is ICBO and ICEO. ICBO is the current due to or the current from collector to base when emitter is open, and ICEO is current from collector to emitter when beta is open. So the relation between the ICEO and ICBO is this: ICEO is equal to 1 plus beta into 1 ICBO. We have already discussed the active region, cutoff region, and saturation region. So how to find the region of operations? We have 4 steps for this. The first one is assume the BJT is in saturation region. If BJT is in saturation region, we will assume that VC is equal to VC sat will be 0.2 for silicon and 0.1 for germanium, and the VB based on meter voltage will be 0.8 for silicon and 0.3 for germanium for NPN configuration. Then find IB and IC. Then calculate minimum base current required to operate transistor in saturation. So calculate IB sat is equal to IC sat upon beta. Then compare IB and IB sat. If IB is greater than IB sat, then it is in saturation region. If IB is less than IB sat, then it is in active region. If IB is negative, then it will be in cutoff region. So this is the end of our lecture or discussion, where we have learned in detail about the BJTs and its operation, working, and everything. Thank you.